Chapter 9, Inheritance and Interfaces, Part 8. So let's look at some self-checks. Suppose you want to use the average method to find the average salary of employee objects. What condition must employee class fulfill? Well, if we implement the measurable interface and provide a getMeasure method, then we can return salary. We have a way to measure that employee object. Figuring out how to measure the objects is worth debate on the class design side, because maybe we don't want to measure employees by salary. Maybe we want to measure employees by employee number to see who was hired first, regardless of how much they make. Maybe we want to measure employees by their name so that we can sort them in alphabetical order. So it's worth thinking these things through and getting a rock-solid design before you ever start to code. So what we're doing in this class is we're focusing on coding. However, it's really important to get a rock-solid design first so that the code that you write is going to be more robust. As you advance in your studies, some people feel more drawn to the design side, and so they go that way, and some people feel more drawn to the implementation side. It's a big tent. There's lots of room for growth and opportunities in different directions. So why can't the average method have a parameter variable of type object with an array? So the object class does not have a getMeasure method. It doesn't. So it doesn't implement the measurable interface. You can't use the average method to find the average length. Why can't you use the average method to find the average length of string objects? Because you can't modify the string class to implement measurable. It's a library class. So we can't change string. It's already provided for us. But we can go about it different ways, as you've seen. What's wrong with this code? Measurable measure equals new measurable. Well, measurable is an interface type. It's possible to have a reference of an interface type. Equals new measurables in interface type. We can't, there's no constructor available with the measurable interface or any interface. So that will not work. We cannot instantiate an object of type measurable. It's not a class. How can you sort an array of country objects by increasing area? So if the country object implements the comparable interface, then you can call arrays.sort. So if public class country implements comparable, as long as you override that compare to method, then you can supply your array of country objects to the arrays.sort. Can you use the arrays.sort method to sort an array of string objects? Check the API documentation of the string class. Yes, because string implements the comparable interface. So there is a compare to method with strings. Therefore, you can pass that string array to arrays.sort. Common error is forgetting to declare implementing methods as public. So when we write it in our interface, we don't need to put public because it's public and abstract by default. However, when we define that method, when we implement that method in our class, we must put public. So in this case, in the gray box, we should have put public double getMeasure. Methods are not public by default in classes, and it's common error to forget to put public when declaring methods from an interface. Private is the default access modifier in a class. Interfaces cannot have instance variables. However, it is legal to specify constants, and I think we brought this up in class and I was going to double check, so here you go. When declaring a constant in an interface, you can and should omit the words public static final, because all variables in an interface are automatically public static final. So here we say int north equal 1. Notice we're still following the naming convention for constants, all caps. Northeast equals 2 and east equals 3 in our public interface swing constants. Generic interface types. A type parameter specifies the type of the objects that this class is willing to accept for comparison. We've looked at typed things before with ArrayList. ArrayList takes a parameter. So this should not be that unfamiliar. The comparable interface uses a special type of parameter to allow it to work with any type, and it's called a parameterized type. The type T is a placeholder for the actual object. So just like with array list, we have array list and then string and angle brackets, that's our type. Names equals new array list and then string and angle brackets, that's our type. We would put our type in for T. So with the bank account class, it can be reworked to use the generic version of the comparable interface. Public class bank account implements comparable bank account. So it makes it a little bit easier because we don't need to do that cast with type object. So function object interfaces work well if all objects that need the service are willing to implement the interface. Excuse me. If you don't implement the interface, if you don't implement the interface, then what good is it? It's not helpful. So the sole purpose of a function object is to execute a single method. This allows for a non-implementing class to use the service of the interface by creating a function object and using its method. So it's just an object that does one thing. First, create the new interface, so public interface measurer, and then that has a double measure object and object as a parameter. The measure method then measures the object and returns its measurement. We use the parameter type object as the lowest common denominator of all classes in Java because we do not want to restrict which classes can be measured. So that will allow us to measure any class. So it would be implemented as follows with public class string measurer implements measurer, public double measure object obj. So we cast that obj to a string and then we return its length. So that gives us a way to measure strings even though the string class does not itself implement the measurable interface. So let's say that we wanted to create a function, example of function object use. We can instantiate an object of the function object class. So previously, our function object was string, our function object class was string measurer. So over here, we can say string angle square brackets words equals Mary had a little lamb. So that's the contents of our string array. Measurer strmej equals new string measurer. Measurer is the interface type and string measurer is the class type. Then we have double result equals average words string mej. So we're calling that average method, passing it our object array and our measurable object.